Hello students, I am Dr. S.R. Gadak, Associate Professor in Department of Physics of KTHM College. Today I am going to deliver a lecture on this subject at MSc 2nd, Experimental Techniques in Physics. And particularly I am going to talk on vacuum techniques, and the topic for today's lecture is capture pumps. As you know, so far we have studied the different types of vacuum pumps. Basically, there are three types of vacuum pumps, and the three types of vacuum pumps are, first of all, positive displacement pumps, then second is momentum transfer pumps and capture pumps. In positive displacement pumps, there are some moving parts of some mechanical pumps, and these moving parts, they are forcing the gas molecules and they are exhausted out of the chamber or the space where you want to create the vacuum. So this is purely a mechanical process. Whereas in momentum transfer pumps, very high speed blades or components, they strike on the gas molecule. In this process, they transfer momentum to these gas molecule, and the gas molecule will travel towards the exhaust. This is how in the first two types of vacuum pumps, the vacuum is created or the gas molecules are forced to move out of the vacuum chamber. But the third type, which we are going to study today, capture pumps, is very different from these two. So let us see what are these capture pumps. So in this particular lecture, I shall give you a brief introduction of what is capture pump. Then second, the very first type of capture pumps, which is known as Gator pumps, in which I shall explain the concept of surface gator and bulk gator. And a particular type of capture pump we are going to study is titanium sublimation pump, and one more I shall discuss today is sputter ion pump. So let us start with the first type, that is the first point, that is the introduction to capture pumps. So basically the name itself, capture, means to capture the gas molecule. So the actual process involved in capture pumps is to capture the gas molecule. In the earlier two types of vacuum pumps, that means the momentum transfer and positive displacement pumps, the gas molecules are actually forced out of the chamber or the space where you are creating the vacuum. But in capture type of pumps, the gas molecules are not flown or forced out of the chamber. Rather, they are captured inside the chamber itself. So this is very green technology of vacuum pumps, where you don't need any mechanized components like motors or moving blades, and therefore no vibration, no noise, no utilization of high amount of electrical energy or any sort of other energy. So this is purely a green technology. So this is a major advantage of the capture pump. Second thing, less noise and vibration. So their operation is very calm. So they are not creating any noise or vibration because there are no moving parts or any such kind of mechanical devices. And third and very important feature of this capture pump is their size is very compact and they are very efficient. Especially gas species capture mechanism can be developed in this particular type of capture pumps. Okay, so let us start with the first type of capture pump, that is Gator pumps. Now the word Gator means what? Gator means to react with. So Gator pump, they actually use the chemical action. So there are certain kind of Gator materials which reacts with the gas species. The gas species are captured and some chemical compounds are formed. So the gas molecules, they are converted into chemical compounds. So there are variety of materials which acts as a Gator. For example, metals like molybdenum, niobium, tantalum, zirconium, aluminum, and titanium. These are some materials which can be developed as surface gators. So these surface gator, they become active in a vacuum pump, and they are deposited, these materials, they are deposited on a surface in the form of thin layer, which is called as the surface gator. And when the gas molecule come in contact with the surface gator, they will be converted into some compounds. So the active gases will react with the gator to form surface compound. So this is the basic principle of operation of gator pump. Now the actual pumping speed of these gator pumps, that will depend upon one important constant, that is known as sticking coefficient. So this sticking coefficient is what? The gas molecule has tendency to get stuck with the surface of the gator, and this ability is defined in terms of a constant which is known as a sticking coefficient of the gas on the surface. Cooling of the gator surface will enhance the sticking coefficient. So if you increase the sticking coefficient, what will happen? There will be more time for the gas species to react with the gator, and therefore they will be getting captured there. So if you want to increase the sticking coefficient, what is essential is you should reduce the surface temperature. So for that you can develop a cooling mechanism which will improve the sticking coefficient in this process. Okay, so another type of the format of material that can be used, that can be a bulk material. So if you use bulk material as a gator, then that is called as bulk gators. And these bulk gators, their operating conditions are slightly different as compared to the surface gator. So bulk gator normally they operates on elevated temperature. That means you need to keep them at a higher temperature. So at higher temperature, you know that these particular gas molecules, they can diffuse through the surface compounds formed on the bulk gator, because bulk gator, as you know, since it is a bulk material, gas molecules, in order to react with the material, that they will need to be diffused inside the material. So their speed, pumping speed here, it is limited by the diffusion of a gas through the surface compound. Okay, so this at elevated temperature, the diffusion rate will definitely increase, and therefore the pumping speed will also increase. So that is what the important feature of this bulk gator materials. Okay, so the particular type of surface gator which is used is titanium, and the vacuum pump which is developed, the capture type of vacuum pump which is developed based on this material, that is known as titanium sublimation pump. It is abbreviated as TSP. So this is basically a surface gator pump. And another type which is known as non-evaporable gator pump, NEG. So it is based on the bulk gator material. Now in case of surface gator, titanium is the best choice. Why it is best choice? There are three important characteristics of the titanium as a gator material. So first is they are sublimated at a much lower temperature. That means in order to create the thin film on the surface, active surfaces inside the chamber, so that the gas molecules can react. So these films can be easily prepared at even low temperature, because titanium can sublimate even at lower temperature. Second point is that they are inexpensive, and third and very important advantage is that the different number of gases, very large number of gases can react with titanium, so forming the chemical compound. So their capturing capability will definitely higher. So let us see how this titanium sublimation pump works. So basically in titanium sublimation pump, there is a bar or a filament which is made up of titanium material, and this titanium material, that is electrically heated by a alternating current source, and when it is electrically heated, the material will get sublimed. Sublimation process, you know, when something is heated, if it is directly converted into gases or vapor, then we say that there is a sublimation. So titanium gets sublimed at by a simple process of heating it. So by heating this titanium filament, the inner wall of your chamber will be coated with titanium material. So a thin layer of titanium will be formed. So the pump elements are fabricated with 3 or 4 separately heated filaments, because when you start the process of creating vacuum, one bar will not be sufficient, or one particular element of titanium will not be sufficient. So simultaneously there are 3 or 4 such filaments placed inside the chamber, and one by one they are heated, so that the process of creating the surface gator will continue, and thereby the process of capturing the gas molecules will also continue. So the active gases, some of the gases, they are very active. So they are captured on the fresh titanium surface, which is cooled with water or liquid nitrogen. So earlier I have mentioned that sticking coefficient is important in order to improve the pumping speed, and the sticking coefficient can be improved by cooling. So for cooling we need either water or liquid nitrogen that can be just used to cool the surface of this particular gator. So you can see this particular diagram here, which is shown, that is of titanium sublimation pump. You can see that particular element which is provided external electric supply, and that can be heated to sublime, so that the surface will be coated with titanium material, and this particular material will act as a gator. So all the gas species, different reactive gases, they will react on the surface of gator and forming the chemical compound. So in this way the gas molecule, they are captured inside the chamber itself. They are not forced to move out of the chamber. They are captured inside the chamber itself. So this is the basic principle of the titanium sublimation pump, how it works. Okay, so a fresh titanium, in order to continue the process of creating vacuum or capturing the gas molecule, what is necessary is a fresh titanium layer must be deposited periodically. So this is possible by just allowing this one by one supplying the electrical energy to the elements and allowing them to sublime, to continue the process of depositing a fresh layer of titanium. Now the pumping characteristics of titanium, it differs for the active gases, intermediate gases, and chemically inactive gases. So you can divide the all gas species present inside the chamber in 3 groups. That is, the first group is active gases, second is intermediate gases, and third is inactive gases. So some gas species are very active, some their activity is intermediate, whereas some of the gas species, they are inactive. So how the pumping mechanism is involved in titanium sublimation pump for these 3 gas species, let us see now. So first group, that is the active gas species. For example, here oxygen, then water vapor, carbon dioxide, these are the gas species. One more, that is acetylene is also there. So these are some active gas species. So they are pumped with very high sticking coefficient. They have high sticking coefficient, so they are efficiently pumped by these capture pump. Water vapor especially, so water first of all dissociate into oxygen and hydrogen, and which are then pumped separately. So this is the first group of the gas species which can be very efficiently pumped by the titanium sublimation pump. The second group, that is the intermediate type of gas species. So intermediate gas species means the gases where the sticking coefficient is slightly lower or intermediate. Their value is intermediate. So we need to cool the gator surface up to lower temperature of the order of 77 degree Kelvin, so that the sticking coefficient will improve, and such intermediate gases, for example hydrogen or nitrogen, is the example of such intermediate gases which can be pumped efficiently, but for that you will have to cool down the gator surface up to 77 degree Kelvin. Now after desorbing, hydrogen will diffuse into the underlying film. Underlying film means the gator material film. Now the third group, that is chemically inactive gases such as helium, argon. So you know that these are inert gases. Then one more, that is methane. So methane is also inactive gas. And for these gases, this particular titanium sublimation pump, this is not that much efficient. So for these particular gas species, including methane, so methane, it has the characteristics of an inactive gas, and this can be adsorbed, or it can be adsorbed on the surface of titanium only a very lower temperature of the order of 77 degree Kelvin. So for inactive gases, this titanium sublimation pump is not a much efficient way of creating the vacuum. So the main points regarding this titanium sublimation pump, one can just see that the replacement of one previously solved gas by another is important here. That means some of the gas species, if suppose one gas species is already adsorbed on the surface of Gator, another gas species will come there and it will replace that gas species and it will form compound. For example, oxygen is the most reactive gas and it can replace any other gases. Whereas if you consider the other active gases, for example, methane is much inactive. So all other gases can replace methane gas molecule. So methane is inactive and it is bound by a very weak van der Waals forces. Now the starting condition for this titanium sublimation pump, you should start at pressure well below 10 raised to minus 1 Pascal. Why we should start at such lower pressure? Because if you try to operate this vacuum pump at higher pressure than this particular value, that is 10 raised to minus 1 Pascal, what will happen? The difficulty is that the pressure above this particular pressure, that means 10 raised to minus 1 Pascal, surface compound formation will inhibit the process of sublimation. So there will be no sublimation of titanium and obviously there will be no capturing mechanism. So one should start this particular vacuum pump at of the order of a pressure of 10 raised to minus 1 Pascal. So that is the starting pressure for this vacuum pump. So this is very important point regarding the titanium sublimation pump. The attractive feature of titanium sublimation pump is that it is free from the oil vapor. So it is very clean. Other mechanical pumps earlier we have studied, these need oil for sealing or lubrication, etc. So the oil vapor can enter into the chamber and contaminating, and the load on your vacuum pump will be unnecessarily increased. So this is not the case for Gator pumps. So in that way, these Gator pumps, they are very attractive. So they are free from oil vapor and their attractive applications where we need ultra clean, non-contaminated environment. So this is the application area. One more drawback related to this titanium sublimation pump is that this is not a standalone pumping method. You need to have some auxiliary pump, and mostly sputter ion pumps, they are used along with this particular titanium sublimation pump, because already we have seen some of the inactive gases like argon, neon, these particular gases cannot be efficiently pumped by this titanium sublimation pump. So what we need that in order to remove these remaining gas species, there should be some auxiliary pump, and a sputter ion pump is the best choice. So the titanium sublimation pump is always used along with some auxiliary pump like sputter ion pump. Okay, so the auxiliary pump is needed to remove the gas species like helium, neon, argon, methane. These Gator pumps, just like a titanium sublimation pump, the application, one of the important application that you can use these Gator pumps in photomultiplier tubes, PMT. PMT, you know that it is the best optical detectors and it is used in many applications. So photomultiplier tube, if you want to evacuate it, the best choice is titanium sublimation pump or this Gator type of pumps. So let us move to another type of Gator pump, rather you can say the capture pump, is the sputter ion pump. So just now we have seen the first type, that is the titanium sublimation pump, and one of the major drawback of titanium sublimation pump is that it cannot remove some inactive gases. So there are some other techniques. For example, cryo vacuum pumps are there. These are also a very good example of capture pump. But there are certain limitations. So what are the limitations? Some of the gas species like helium or hydrogen, you can see here in this particular graph, I have shown the curves for the vapor pressure at a different temperature for some of the gases. So you can see here helium and hydrogen, these two particular gases, they have substantial vapor pressure even if you come below 10 degree Kelvin. So the difficulty is that they cannot be even condensed, or they cannot be even cryosorbed. So what is the alternative? The alternative is you can use the sputter ion pump to remove such gas species which cannot be removed by the titanium sublimation pump or some cryo pumps. So here the only solution is sputter ion pump. So let us see now how these sputter ion pumps works. So basically these sputter ion pump, one should call them as ion Gator pumps, not only sputter ion pumps, but they are ion Gator pumps, because simultaneously in these pump the sputtering process along with gatoring process, both are working together in order to capture the gas molecule. So it is better way one should specify it as ion Gator pumps. So both ionization and gatoring mechanism are involved here. The purely ionic pumping mechanism, along with the pumping due to freshly deposited titanium gatoring film by the process of sputtering. So in this particular sputter ion pump, the titanium as a Gator material is also used, and the sputtering process is used to ionize such inactive gas species which cannot be removed by Gator pump. So once they are ionized, later they can be captured. How? Let us see. So this is what the sputter ion pump. The basic element of sputter ion pump is the penning cell. So the main concept on which these sputter ion pump are based, this is a penning cell, and the mechanism involved is called as penning discharge. So let us see this, what is this penning discharge and what is this particular mechanism of sputter ion pump. This one can see from this particular diagram. So there is a cell, that is, you can call this cell as a penning cell. Okay. So the cell, or simply it is a diode. Why it is a diode? Because there are pair of the electrodes, you can say cathodes and anodes. Okay. So a cell is a diode consisting of short cylindrical tube anode A. So you can see this yellow A anode, cylindrical anode placed exactly at the center. Then this particular anode is made up of stainless steel. So the material that is used to prepare this particular anode is stainless steel, and two cathodes. You can see at the two sides of this particular centrally placed anode, there are two cathodes. So these two cathodes, they are made up of titanium. So you know titanium is the best gatoring material. So this titanium will act as the gator material as well as cathode in this particular penning cell. Now let us see the dimensions. The anode is cylindrical, and it has 15 mm diameter. Its diameter is 15 millimeter. Then the length is of the order of 20 millimeter. And the cathodes, two cathodes to the two sides of anode, you can see, and the distance between this anode and cathode on each side is of the order of 4 mm. So this is the structure of this particular cell. Now two types of that are used in the this particular penning cell, or what we call as sputter ion pump. So we use the magnetic field as well as the electric field. So on the two side, you can see in the symbolically I have shown the magnetic fields here, north pole and south pole. Okay, but the strong magnetic field of the order of 0.15 Tesla with the help of some permanent magnet that is used here. And this is outside the particular stainless steel case, which is actually acting as a chamber for this process of sputtering inside this particular chamber. So this casing is made up of stainless steel. It is denoted by letter A in this particular diagram. And you can see the another field, that is a very strong electric field, is also applied here. So how it is applied, you can see in this particular diagram. So the two cathodes, they are combined together and they are earthed. That means they are connected to ground directly here. And the anode is kept at a very high potential of the order of 3 to 7 kilovolt. So a strong electric field and strong magnetic field, both are applied in this particular case. Okay, so the discharge in this particular penning cell, it is initiated either by creation of electron because of some cosmic ray interacting here, or the electrons can be produced by field emission at the cathode. So, by any of this way, initially the electron can be initiated. Once the electrons are produced, then they will be accelerated. So, because of very strong electric field present here, the electrons will be accelerated. So, its acceleration due to anode is further prevented by the magnetic field present over here. So, magnetic field is also very strong, and as you know, in basic electromagnetism, you have studied the motion of the charge carrier in presence of magnetic field, that the force is acting on such electrons, and the force is F is equal to V cross B, where V is the velocity of that charged particle and B is the strength of the magnetic field. So, because of this force, what will happen? The electron will spiral around the magnetic field line. So, you can see I have shown the magnetic field line here along that particular cylindrical anode. So, the cylindrical anode there, along its axis, the magnetic field is shown. So, the electron will spiral around this particular central anode. So, what will happen because of this? So, the cascade of ionizing collision. So, while spiraling this electron, there will be collision. These electron will perform collision with some gas molecules, which will meet them in their path. So, each of these collision will yield a positive ion and a electron. So, you know that when very strong, highly high momentum electron strikes on the particular gas molecule, there will be ionization. So, positive ion and electron will be produced over there. So, because of that, large number of such positive ions and electrons will be produced. So, these electrons will form a electron cloud, and this electron cloud will be trapped in the anode cylinder, and this magnetic field will confine this and restrain axially by the cathodes, which are placed at the ground potential. So, the electrons follow long lasting spiral trajectories around the field lines back and forth between the cathodes. So, electrons will travel over a very long distance, and the benefit is that they will perform more collision with the gas molecule and there will be further more ionization. So, these large number of electron, and because of which a large space charge is formed here, so that will cause a potential along the cylindrical axis here, and especially in the central region between the cathodes, slightly below the cathode potential. So, as a result, the electric field within the cylinder is radial. The electric field is radial and therefore perpendicular to the magnetic field. So, electric field and the magnetic field is perpendicular. So, because of electric field, the electrons will be accelerated, but they will not directly move toward the anode. There is a radial force because of the magnetic field, and therefore they will perform a spiral path. They will perform number of collisions. Once the energy decreases, then finally they will discharge through anode. So, outside the cylinder space charge region, the electric field becomes increasingly axial and therefore reflecting for the electrons. So, in this particular case, they will not directly reach the anode. Now, what will happen to the ions? So, that one must consider here. The motion, spiraling back and forth motion of the electron between the cathodes, it is accompanied by a rotation of charge cloud about the central axis due to the E cross B, this particular drift, and this phenomena is very important, which is known as a penning discharge. This is what is known as penning discharge. So, this rotating cloud is the principal characteristics of penning discharge. The high electron density in the cloud means that there are many ionizing collision of electrons with the neutral gas molecule, and each one producing ion and electron. So, the electron remain in the discharge process, and the excess of electron urge outward by the electric field, but they are constrained by the effect of magnetic field and they will diffuse slowly. So the process of discharging the electron towards the anode is very slow. Meanwhile, they will perform number of collisions. Now, what will happen to the positive ions? Let us see now. So, these positive ions, they are relatively having greater mass, so they are not much affected by the magnetic field present here. So, they will be accelerated because of the negative potential towards the cathode, and they will strike on the cathode material. So, cathode, as you know, they are made up of the titanium material. So, because of the impact of ion on this particular cathode, what will happen? The sputtering process will take place. That means the titanium will be sputtered in all direction, and it will be deposited on the anode, the inner wall of the casing, and everywhere. And therefore, it will act as a Gator material. So, the gas molecule, the reactive gas molecule, they will react on this surface and they will get captured. So, even if the inactive gas is present, it is, since it is ionized, and the positive ions, when they strike onto the cathode, some of the ion they will get buried deep into the cathode material. So, the outer region of the cathode is built up with time. So, what, because of the high collision with the cathode material, the central part will get corroded. So, the outer part will remain built up and the inner part will erode, forming the depression over there. So, the freshly deposited titanium surfaces will pump the neutral gas molecules. The active gas species like nitrogen, carbon monoxide, etc., they will be adsorbed by titanium material and they will be efficiently pumped. The pumping is enhanced if the molecules have been dissociated or otherwise excited in the discharge region. So, the ionization process will help another inactive gas molecule to get pumped. How? Let us see here. So, the true ion pumping, in which some of the energetic incident ions penetrate deep into the cathode to become buried as stable trapped compound. So, the ionized gas molecule, especially inactive ionized gas molecule, they will strike onto the cathode and they will get buried deep into the cathode material. However, depending on their location, some may later release by resputtering. So, some of the ions they may be further released, but this process continues, and most of the inactive gas species they will be captured in this process. So, you can see in this particular diagram, I have shown the different components involved in this process of sputter ion mechanism. So, the solid black, you can see there, that is a titanium atom. The pink one, that is the gas molecule. Then the positive yellow spherical shape I have shown for ion, and the bluish one spherical, that is the electron. So, you can see the ions, they are striking on the cathode and the central part is eroded. The cathode central part is eroded, you can see here. And the black, the titanium atoms, they are deposited everywhere. You can see on the anode surfaces, on the other cathode surfaces, the casing surface, everywhere. Okay, so what will happen? Some of the inactive ion, they will get deep buried into the cathode material. Some of the gas species, they will be buried on the surfaces of the anode. You can see the pink one I have shown, gas molecule, it is buried below the black one, that is the titanium atoms, which are sputtered because of striking of the ion on the cathode surface. So, this is a simultaneous process, sputtering as well as Gatoring. So, for sputtering, the ions are striking on the cathode, and meanwhile the titanium is sputtered and it is deposited, and that will act as a surface Gator. So, from both way, active gas species and inactive gas species, they will be captured here. So, in this particular diagram, you can see all these details. So, the mechanism just now I was talking about is principally at the anode surface. So, the simple burial of gas molecule under the titanium atom. So, that is also one of the interesting feature of this particular type of capture pump. So, the gas molecule that are captured in the titanium deposit on the interior anode surface stay trapped because this region is not subjected to ion bombardment. cathode is subjected to ion bombardment, but anode surface you can see it is the ions are not subjected to be colliding on the anode surface. So therefore, they are free from such collisions, and therefore the gas molecules can be easily buried over there. So active gas species are captured on the surface of Gator to form chemical compounds. Ion pumps, in this way, they are better as described as ion Gator pumps. So instead of saying only sputter ion pump, one can specify them as ion Gator pump. So simultaneously, both processes are taking place there. In sputter ion pump, both electric field and the magnetic field that is used. So you can summarize overall these two pumps which I have described here. These are the three main key point here. So sputter ion pump, in which we have used both electric as well as magnetic field. So this is all the main key points of my today's lecture. I want to give some questions as an assignment here. The first question is on what are the advantages of capture pumps. In the very first topic, I have explained, if you see the very first part of my lecture, the detailed advantages of capture pump I have described there. Then second question is, what are the suitable Gator materials? I have listed various material like titanium, niobium, zirconium. So all these are the different Gator materials. And one more question, explain the working principle of sputter ion pump. The second type of pump which I have explained there, that is the sputter ion pump. The working principle also I have explained, that is the penning cell and the penning discharge, that is the main concept, use of both electric and magnetic fields. So both these points I have very much explained in detail in this particular case. So in the next lecture further, there are some other types of capture pumps also. For example, cryo pumps, which are based on cryosorption and cryodesorption. So both these type of pump will be discussed. Then one more type, that is orbitron pumps, are also there. These are also a type of capture pump. So both these types we shall study in much detail in the next lecture. Then the triode type of sputter ion pump, that is the one more type of the capture pump. So for more details on this particular topic, you can refer these references. The first reference, Vacuum Technology by A. Roth. Second, Methods of Experimental Technology, volume 14, edited by G. L. Wessler, published by Academic Press. And the third is Modern Vacuum Physics by Austin Chambers. So this is also a nice book. You can refer all these three references for further details. Thank you. This is all in my today's lecture.